So if you don't mind, let me take a moment to explain this to you. Why are they holographic? And what do they have to do with our subframes? So, our modification of the subframe from the first version to, hopefully, the final one actually started with these washers. That is, we had concerns about the silent blocks rotating between the lugs, since the lugs are made of aluminum, which is a soft metal, so the steel sleeve of the silent block could potentially spin inside them. To address this, we decided to reinforce the aluminum surface, and for that, we machined these washers. They have ribs, and when these are installed under the silent block, like this, with the silent block positioned inside, not outside, they are pressed firmly and securely into the aluminum body by the bolt. Since this particular aspect was our main concern, we started thinking further. That is, if we're already modifying this assembly, we should also consider the other issues with this subframe. And we carefully wrote down some of the problems we noticed during assembly, about a page and a half worth. There were 15 points, and we set about fixing them. As I mentioned in the previous episode, our reference was for steel, but we made it out of aluminum. So from there we moved on to fully adapting the architecture for aluminum. We started with these washers and then continued from there. Now everything here is 5 millimeters thick. That is, there used to be some 4 millimeter plates installed here, but now everything is 5 millimeters thick. Then we added some additional reinforcements, and the assembly scheme itself has also changed. At the bottom, we have the lower plate in place. It wasn't the lowest point before. It was inserted into these side plates. This caused some inconvenience during assembly. And here, an extra gap would appear. We noticed this during the welding stage. In other words, it was hard to reach in there. A bend would form here. We changed it. Now it's flat. This is 5 millimeters and it's the lowest point of the subframe. So, if there are any impacts, it will take them. Also in this case, this plate was not fully welded. Additional mounting tabs for the removable part of the subframe were welded onto it. The main frame of the subframe skeleton is assembled as a single welded piece. And there is only one element, which is also welded separately and attached as a part. This is the removable cover with tabs, along with the suspension system and other associated components, such as brackets and fasteners. As you can see, initially we wanted to make a square for the tow hitch, but since it's made of aluminum, naturally this is a very weak part, especially since it was planned to be made of 4 millimeter steel. So it was immediately clear and obvious that it wouldn't be able to withstand these kinds of loads or stresses. Moreover, the rear part of the structure was also attached right here with bolts in the previous design, which was used before. That's why we switched to this design. Here the part is already solid. It is welded to both sides. The cover is welded on. Here too, the cover is made of two parts, but here we have a solid cover. The cover is made from 5 millimeter material and is already welded to both the rear and front plates. The bolts you see in this part are for attaching the removable section. Accordingly, the cover itself is now a solid piece together with the subframe. Here we had welding to this plate, which by itself was weak. Here, our plate is installed properly, it's sturdy. And in order to make this square out of steel, since the trailer has varying thicknesses and loads in different directions, and aluminum is very sensitive to that, we distribute this load onto a plate like this. It's located right here inside, specifically just under the mounting hole, meaning it's securely fastened with small bolts inside the subframe, threads are carefully cut into it, and then the outer part, the square receiver, is then attached to it. The pressure from the hitch is then distributed more evenly across this plate. As you can see, here we also have the firewall. In this part, it is welded to a fixed plate, and in this part, it simply had tabs. From the inside, this is clearly visible. Here, tabs were welded to it as well as to the lower plate. As you can see, this was a tab. It's not solid, just pieces welded on, and this plate was bolted to them. Then, all of this was supposed to be attached to the body through these upper holes. First of all, this plate is again made from 5 millimeter steel, not 4 millimeter. It is already welded into the overall contour. It connects to the top. The weld runs all the way to the edges. As a result, the part has become much more rigid. The engine mount itself has remained as it was. And the mounting of this part, which has already been aligned to the body, has also been preserved. In my hand, I have an exact replica of Igor Negoda's hand. We are going to apply it to our project. There was no welding here, So in the rear part, this cover was basically hanging in the air, you could say. It wasn't reinforced. The situation was essentially the same here as well. However, in the new subframe, we already have welding present on the upper plate right here, because it is a single unified part. Now let's take a look at the engine shield. There aren't that many changes in it. As I said, it's the thickness, and this element has been added. This is the breather outlet for the gearbox. That is, our gearbox is now located in the water. Accordingly, the breather tube runs into the main sealed compartment. Then the upper parts of the ATV are installed. Most likely that's the handlebar area. Basically, it's set at the maximum height so that water doesn't get in when crossing water obstacles. Next, this subframe is now completely ready and prepared for assembly. So we're going to carefully put on all the remaining parts and show you what it looks like as a whole. So, 2 of the control arms are already pressed into the bushings, everything is in its place, and we'll show you the process for the other 2 now. As always, using internet life hacks for the process, we're pulling the studs through. The first bushing was inserted through this eyelet, and we held it in place, making sure it was properly aligned, and at that time the stud was long enough. Now, however, the length is not sufficient. So we take a socket of the correct size, brace it right here, and repeat the same procedure with the second bushing. We spray some plain water, just to make it slide a bit more easily. We take a wrench. Now next, let us continue forward to the next section. After pressing in the bushing with the hook, it settles into its place. Assembly is done as follows. A washer with a knurled side is put on the bolt. This side goes into the body. The last washer goes here. The control arm is assembled, the bushings are in place, everything is ready for installation. Next, we will install this off-camera, since the initial installation of the washers is a bit tricky, but after the first installation, the washers are tightened, pressed into the aluminum, and they won't move from their places anymore. Accordingly, replacing the control arm in the future won't be as complicated as it is during the initial assembly.
Hello, my name is Alexander. I work as a process engineer at our company, and we manufacture parts. Often parts are sent to us whose intended purpose I do not know. Recently, we received a drawing of this particular part. I can show you the model of the part. Here is its drawing. The drawing is intentionally simplified for in-house production purposes without GOS standards or tolerances. The rest of the tolerances are communicated to us verbally. We write the program in SolidCAM software specifically for machining operations on a turn mill machine. This is a Haas ST-20Y with a driven axis and a driven head. The part is fully machined in a single setup, meaning it is turned, drilled, and milled. The milling operation has finished, and now the part is being carefully cut off. Starting from a blank piece like this, which is a 30mm diameter rod, every 10 minutes we get a finished part just like this. So it's a turning operation with milling elements. Here is the finished part. It can be removed by hand. We don't cut it off completely so that it doesn't fall and accidentally damage the edges of the material. You can simply and very carefully pull it out by hand, making sure to do this slowly and gently. Here is the finished part.
After carefully trimming the washers, we are left with a distinctive pattern. These pronounced ribs effectively prevent it from rotating. In the case of aluminum, they help to distribute the load more evenly and allow this part to last for a very long time without damaging the mounting points in the softer material. The drum assembly is complete. As you can see, everything comes together quickly and without any complications. This is already an almost finished product. All that's currently missing here is the motor, which still needs to be installed, and this particular part is already fully prepared and ready for painting except for just one single element. This is the shock absorber bushing. That is, the entire painting process will come later, because first we need to check the whole suspension assembly and take it for a test ride. Well, as you can see, we weren't wrong about the week. Accordingly, the extra shock absorber mounts will be removed. Most likely this is their position. We've already done some preliminary tests there, so it's roughly at this point, but we'll check it again specifically during the road tests. After that, the subframe will be disassembled and painted, and the control arms will be painted as well. And then it will become a part for the ATV. It will go into storage to wait for assembly. Accordingly, the next step is moving on to the front subframe, which you'll see in the next episode. See you next time.
Subscribe to the channel, hit the like button, and stay tuned for the new video.
So here's a little spoiler for the next episode. As you remember, in one of the previous episodes, our voltage converter failed. Its capacitor blew, so it's being scrapped. And now, right in front of you is the new converter. This one is rated for 80 amperes. That means this plate is directly connected to the water block for heat dissipation, so there won't be any overheating issues like we had here. A couple of words about why the problem happened here. We didn't have any thermal paste, and the heat dissipation wasn't working properly. As a result, they overheated, high voltage broke through to the output stage, and the capacitors failed.